Every day, millions of goods move across the globe by land, sea, and air, powering industries and connecting communities. But this essential movement comes at a cost. Freight transportation is a major contributor to global CO2 emissions, and as demand for goods continues to grow, so do its environmental impacts. Decarbonizing heavy-duty transport is one of the toughest challenges in the fight against climate change. Trucks, ships, and planes require energy-dense fuels to carry heavy loads over long distances, and each mode of transport has its own unique fuel and performance requirements. Biofuels offer a promising path forward, but their production must be both scalable and sustainable, derived from non-food biomass and waste residues that do not compete with agriculture or harm ecosystems. Achieving this requires advanced technologies that can efficiently convert diverse bio-based residues into fuels tailored for different transport applications. Jose Antonio and Tomas, two researchers from the University of Seville, explain how the FLEXBY project can help make this possible.
FLEXBY is a multidisciplinary project gathering aspects from chemistry and chemical engineering, and it aims to decarbonize the transport sector by developing a new technology for heavy transport biofuels.
The main problem is that you never can imagine that you fly using batteries, because all the planes should be plenty of batteries, so this is not possible. It's the same as for shipping. You cannot run in batteries, so you need a fuel that cannot produce emission.
Exactly. Essentially, we believe that in the future, light transport, like motorbikes and cars, will be electrified. But we think that for heavy transport, like shipping, aviation, etc., we need a new generation of biofuels. It's the only way to power these heavy cargos. FLEXBY is actually attacking that angle from a scientific point of view. This project is supported by the consortium of both academics and industrialists. And together, we gathering forces to go from lab scale. Today, you are visiting our lab in Sevilla, from lab scale to pilot scale. So at the very end of the project,
we have to finish with
exactly,
the pilot.
At the very end of FLEXBY, we are going to have a demonstrator showcasing how we can input a bioresidue and collect finally certain amount of biofuel that can be useful for heavy transport industry. So this is the key point. Let me reiterate, we are trying to decarbonize the transport sector. Jose brings a very important aspect of FLEXBY, using a flexible technology. Our technology aims to get any kind of bioresidue and produce a final biofuel.
FLEXBY.
So to do that magic, we need a number of chemical processing steps, including catalysis, microwave technology, process engineering.
And we have to go from the very basic to the final product. That combines a lot of technologies. We need to prepare reactors, way of heating that reactor, because we need heat, and this should be also efficient and zero residues. The main top point of the project is it's flexible.
Yeah, flexibility.
With this technology, this combination of reactors and so on, we may change the final product, and not enormously, but a little bit, to adapt to the different ways of transport.
Yeah, and beyond technical concepts, beyond chemistry, we are here addressing a very important chunk of CO2 emissions. We need to take action immediately on that, and this is why FLEXBY will be one of the, in our opinion, of the main contributors to the next generation of biofuels. Another important element of FLEXBY is the circularity element, right? So we are departing from bio residues and bio stuff that are, for certain industries, are a problem. And we are turning a problem into a virtue. So a waste into a final product, which is marketable product, something that can be in the biofuel market, helping to decarbonize transport sector.
We plan not to have any waste, zero waste, and we plan to do it at a competitive price and enough quantities, and also flexible. Because one of the problems of biomass is flexibility. You cannot expect to have always the same biomass.
The bioresidue has a very different chemical composition depending on where it's coming from. So flexibility is a very important aspect that FLEXBY is unique in offering that option. We have a team of young researchers doing PhD and postdoctoral projects across the consortium, getting trained in technologies, in biofuel technologies, These people will be the future leaders in the area of biofuels and decarbonization. So they get training. This is a very important, if you want, educational, social aspects of bio.
And also, as we are teachers, our main products are people, educated people. We also use this to educate people to get technicians, technologists, scientists for the future concerned with the environment, with the climate, and with enough preparation to develop the future.
That's a big question also for society.
How much you want to pay?
FLEXBY fuels might be slightly more expensive at the very beginning than the standard fuels we have right now. But are you willing to pay a little bit more for your flights, for your buses, trips, etc., knowing that you are making an enormous benefit for society? And by the way, eventually those costs of the new generation of fuels will be reduced until we match up the current situation. But for a while, there's a transition period that we need to bite that bullet and make sure that we as a society contribute towards this sustainable situation. I think that's a very important message for everyone. No matter what we do here in chemistry, chemical engineering, we those researchers can do fantastic things. But the first thing to do is to change mentality. So we need a mentality transition across society to move to something that is creating a problem, global warming, to a more sustainable society. So reduce consumption, reduce different elements that create emissions, and move towards sustainability.
FLEXBY is redefining biofuel production, transforming waste into energy using sustainable, low-carbon processes that are resource-efficient, minimizing environmental impact, and paves the way for a cleaner, more sustainable future in heavy transport.